All right. In statistics today, we're looking at measures of variation. Variation is important in describing data sets. What is variation? Well, variation is how a data set varies or how it's dispersed, how the numbers are different, and how they're spread out. That's what variation is. We have that with range. Range tells us variation a little bit. It's the highest number minus the lowest number, so we can see what the difference is there from the highest to the lowest. But the range is really kind of limited to how well it tells us about variation in the data set. Now, to better understand variation, we have what's called standard deviation. And standard deviation is what we're going to look at mainly in this section. We'll explain standard deviation in just a second. One thing we do need to know, though, is in a data set, we have the population versus the sample. Remember now, population is the whole entire group. Your population could be all the students at one particular school. That's the whole population of that school. Or your population could be all the workers at the Save-A-Lot. Your population might be a group of people that are part of a certain organization. So that would be your population. But a sample now is just a part of the population. So like if we are wanting to describe a population that's too big to calculate, like maybe we want to figure out what the whole country is thinking about something. We can't find out what everybody in the whole country is thinking because there's too many people to ask the questions to, and it's too time consuming. So we might get a sample, which is just a group of people from this population. All right, well, so that means we have a population mean and we have a sample mean. Now the population mean is this little symbol right here. It looks like a U. I kind of messed up the first time I drew it. But it's basically like a U, like this right here, but it's got this little thing comes down like that. Now this is called a mu, is what we call this, mu. Sounds like moo, like a cow moos, but it's mu, M-U. And this is a Greek letter. This is what we use when we're talking about the population mean. Now the sample mean, we just use X bar, and we just say this X bar is how we say this. And this is the symbol we use for the sample mean, okay? Which, when we calculate standard deviation, we first find the variance. All right, so we have a population variance, which uses the Greek letter sigma. Now we have a sigma like this. This is uppercase. And then we have a sigma like this, which is lowercase. Okay, these are both sigma. This sigma, capital sigma, we use to find a sum of a data set. This lowercase sigma is my population standard deviation is what it is. But we use that for variance. It's when this is squared, that's the variance. We usually find that first. When we're talking about a sample, we just use the letter S. S squared is my variance. Sigma squared is my population variance. S squared is my sample variance. Sigma squared is my population variance. And then if I take the square root of those, I get the standard deviation. So standard deviation is just sigma for a population, whereas sample standard deviation is the letter S. So we have two different things here. Okay, and we'll get into those a little bit just here in a second. We're going to look at some problems, and we're going to start on number 3, and we'll come back to number 1 and 2. But first off, we're looking at range here. So number 3 says, find the range of the data set represented by the graph. So here's my graph right here. Okay, well, all you do for range, you take your highest one, which is 34, take your lowest one, 24, and you subtract. So 34 minus 24 is 10. There's my range. Okay, so my range is 10. All right. Here's another one, number 4. We've got this dot plot here. Find the range by the dot plot. Well, here's my highest one right there, which is 97, 98, 95, 96, 97, 98. And my lowest one's right there is 75. So I do 98 minus 75. That's 23. So that's my range. Okay. And then number 5 here, we've got all these, we've got the depths in inches at which 10 artifacts are found, are listed here. So these are the depths that these artifacts were found. Okay, we want to find out what the range is. All right, so I've already calculated or located the highest and lowest value here. So I just do 44.7 minus 23.8. Okay, so it's going to be 0.9, that'd be 0, that'd be 20.9. So there's my range. Okay. Now, part B says here, what if we change 44.7 to 53.1? What would my range be then? So basically what I'm going to do is I'm just going to change this number to 53.1, and I still got the 23.8. Okay, and I'm just going to subtract my highest minus the lowest. Okay, so that's going to give us a 3 there. It's going to give us a 9, 29.3. All right, 29.3. And that's my range. Okay. This next one here, we're still talking about range a little bit. And this says the depths in inches at which 10 artifacts are found are listed. So here's a similar problem as what we just talked about here. All right, the range of the given data set is 23.7. If the current maximum, which is 46.9, is replaced with 57.2, the range becomes 34.0. Okay? It says compare these values and determine how outliers affect the range of a data set. Now what an outlier is a number that's outside of the norm. So like if I replace 46.9 with 57.2, that's quite a bit of difference, and that's going to make this as an outlier, because if you notice these depths here, they're like in the 20s and 30s. So this one's quite a bit larger number. And so that's going to affect the range pretty good here. So I think we're looking at A here. The range is greatly affected by this change. So my answer would be A. So when you have your highest or your lowest is extended, which becomes an outlier, that's going to affect the range drastically. And that's the downfall on range. Range doesn't really help us much when we have outliers, and it doesn't describe much about what the variation is. All right, now number 7, we're getting into one here now where we're going to have to calculate the standard deviation. So we'll work through this one here. I'll show you how to find the standard deviation right here. The number of regular season wins for 10 football teams in a given season are given below. Determine the range, the mean variance, and the standard deviation of this population data set. Now look here. This is a population we're talking about here. So apparently these 10 football teams are all 10 football teams that are in this conference or whatever, or in this division. Okay, so we're going to find the population standard deviation is what we're going to do here. All right, well first the range. We want to figure out what the range is. Okay, well the best thing to do now before we even start anything is to put these numbers in order. That would help us tremendously. So if I look through here, it looks like 2 is the lowest. So I'm going to mark out 2, and we'll write 2 right here. All right, then let's see here. I got 8, 5. I got a 4 right here. 4 is next. Okay. Then I've got a 5. Okay, then I've got 8 there would be next, I guess. And I'm seeing how I'm marking these out as I go on. That way I don't leave anything out. And then look here, I got 2 9s. Then I have a 10. Then we've got a 13, a 14, and a 15. 13, 14, 15, and that would be all of them. So 13, and I'm running out of room here. So I'm going to write these over. So I've got a 2, 4, 5, 8, 9, another 9, a 10, 13, 14, 15. Okay, so here's all my numbers. Okay. Now I want to make sure I have them all. So look here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 10, and that's what it said I had here. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there's all my numbers. So let's just move this over. Okay. And now we're going to find the standard deviation. Now, first thing I do is I got to find the mean of this. So I need to find my mu. And let's see if I could back this out a little bit because it's all right, so I've got them all wrote out here. So I'm going to add these up. All right, so I'm going to bring my calculator in here. We're going to add these up. I've already done it once and got 89, but you always want to do this twice. So I'm going to add these up. So I got 2 plus 4 plus 5 plus 8 plus 9, and I got 2 9s, so I'm just going to go times 2. Plus 10 plus 13 plus 14 plus 15. And see there, I got 89 again. So you always do this twice. All right, so I add these up, I get 89. All right, that's my sum, which is capital sigma. Okay. Now, there's 10 of these, 2, 4, 6, 8, there's 10 of these, so I divide this by 10. I put a double line there. I divide this by 10, which is 8.9. Okay. 8.9 is my mu. That's my mean for this data. Okay. So now that I've calculated the mean, I'm going to take each one of these and I'm going to subtract the mean from it. So, like right here, I'm going to do 2 minus 8.9. I'm going to do 4 minus 8.9. And I'm going to do that for all these. But I'm not going to stop there. I'm going to square them. And we'll write these numbers over here. So I'm not going to write all this down. I'm just going to do the calculations and then write the calculations over here, because that's really what I'm concerned about. So let's get my calculator here. Okay. I'll put it over here on this side. All right, so I'm going to do, let's clear this off, 2 minus 8.9. I hit equals, and then I hit square and equals, and there it is, 47.61. Then I go 4 minus 8.9 equals, square it, equals 24.01. Okay, now do 5 minus 8.9 equals, square, equals. Okay, this is going to be 15.21. I'm going to do 8 minus 8.9 equals, square it, equals. All right, that's going to be 0.81. And I've got 9 minus 8.9 equals, square it, equals. All right, that's going to be 0.01, and then this is going to be the same here, since that's 9 also. Okay, I'm going to do 10 minus 8.9 equals, square, equals. That's 1.21. 13 minus 8.9 equals, square, equals 16.81. All right, then I got 14 minus 8.9 equals, square, equals 26.01. Okay. And then one more, 15 minus 8.9 equals, square, equals 37.21. Okay, and so I subtract the mean from each one of these data entries, and then I square that. Now when I square, now no matter what, see if you notice when I do 2 minus 8.9, it's negative 6.9, but when I square it becomes positive. So all these numbers over here, you should never have a negative. Every one of these right here should be positive. Okay, that's a big thing right there. You got to remember, all these should be positive, never negative. Now after I have these, I'm going to add these up. Okay, and again, you want to do this twice. All right, so I'm going to try to go through there twice. Let me put my calculator up here this time. Okay. All right, so let's see here. We got 47.61 plus 24.01 plus 15.21 plus 0.81 plus 0.01 times 2, because I got 2 of these, plus 1.21 plus 16.81 plus 26.01 plus 37.21, and that comes up to 168.9. Okay, now we'll do it again. You can fast forward through this if you want to, but you always want to do this twice because you could have made a mistake punching it in. 47.61 plus 24.01 plus 15.21 plus 0.81 plus 0.01 times 2 plus 1.21 plus 16.81 plus 26.01 plus 37.21. All right, got the same number this time, so I think I'm good. I did it twice, got the same number both times. Okay. All right, so this is my sum of this column here where I'm squaring the differences from the mean. The differences from the mean squared. I add all these up and I get this right here. Okay, now here's the difference. Like I said, now you have population versus sample. Okay, you got to know which one you're doing. Well, this one we're doing a population, which means this. I'm going to divide this by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to divide this by 10. Okay, when I do that, I get 16.89. Okay, this right here is my variance, which is s squared. This is my variance. Okay, now if I was doing a sample, I would divide by 1 less. You subtract 1 from how many you have. So if I'm doing the sample standard deviation, I would divide by 9. Okay, but we're doing this population, so I divide by 10. There's 10 of them, so I divide by 10. There's my variance. Okay, so let's go back to this page here. Okay. I think my range, we didn't do that. My range, 13 minus 2 would be 11. Okay, my population mean, we didn't write that, but it's right here, 8.9. Now here's my variance. We just found the variance, which is 16.89. Okay, and now my population standard deviation. Now all you do is, okay, you take the you do the square root of that answer. So I'm going to do the square root of 16.89, which is 4.1. Let me write this down here. 4.109744518. This is what I get right here for my standard deviation. Okay, now look, you got to read these down here. It says round to the nearest tenth. I didn't round this one to the nearest tenth, so this would be wrong. I need to round it, which the 9 makes the 8 go up, so this would be 16.9. Okay, not this. And now my standard deviation, I round that 4.1. The 0 does not make the 1 go up. 4.1, and that's my standard deviation. Okay. All right, so now go to this next problem here. Okay. All right, so on this problem, the ages in years of a random sample. Now look here, it tells us right here this is a random sample. So we're doing this sample standard deviation this time. Okay, so these are their ages and years of a random sample of shoppers at a gaming store. Determine the range, mean, variance, and the standard deviation of the sample set. Okay, so I've got the numbers already ordered. Okay, I went ahead and did that prior to starting the video. So the range, 23 minus 12 is 11. All right, the mean, I've got to add these up and divide by, is it 10? 2, 4, 6, 8, yeah, it's 10. So you bring my calculator in here, all right, and so here I got 12 plus 13 plus 15 plus 16 times 2, because there's 2 of those, plus 17 plus 18 plus 19, and I got 2 of those, so times 2, and then plus 23. All right, when I add that up, I get 168. Okay, now always do it twice to make sure I didn't make a mistake on my calculation. So 12 plus 13 plus 15 plus 16 times 2 plus 17 plus 18 plus 19 times 2 plus 23, and I get 168 again, so I think I'm good. All right, well, there's 10 of those, so I'm going to divide this by 10, which is 16.8. Okay, this is X bar. Okay, it's X bar because it's a sample. Okay, this is a sample, so I'm doing X bar. All right, so this is 16.8. That's my mean. Okay, now what's the variance? All right, so now what I'm going to have to do now, I'm going to take each one of these, I'm going to have to subtract the mean. So right here, I'm going to do 12 minus 16.8. I'm going to square it and get that answer here. I'm going to do 13 minus 16.8. I'm going to square it, and I'm going to put that here. I'm going to do that for every one of these. Okay? All right, so I'll bring my calculator back in. Okay. So 12 minus 16.8 equals, square it, equals 23.04. 13 minus 16.8 equals, square it, equals 14.44. 15 minus 16.8 equals, square it, equals. This is 3.24. 16 minus 16.8 equals, square it, equals. I got 2 of these, that's 0.64. Okay. 17 minus 16.8 equals, square it, equals. That's 0.04. And I've got 18 minus 16.8 equals, square it, equals 1.44. 19 minus 16.8 equals, square it, equals. And I got 2 of these, so that's 4.84. And then I got 23 minus 16.8 equals, square it, equals. And this is 38.44. Okay, so there you go. All right, well, I got to sum all them up. So I got to add all these up here, okay? All right, well, I got 38.44 on my calculator already. I'm going to add 4.84 times 2 of those, plus 1.44 plus 0.04 times 2 of the, oh, no, I don't have 2 of those. So go back and take that off. Plus 0.64 times 2 of those, plus 3.24 plus 14.44 plus 23.04, and I get this right here, 91.6. Okay, now I'm going to add them again because I could have made a mistake there, so I'm going to go through them again. 23.04 plus 14.44 plus 3.24 plus, oops, hit minus, plus 0.64 times 2 plus 0.04 plus 1.44 plus 4.84 times 2 of those plus 38.44. 91.6 again, so I think I'm in good shape. Okay. All right, so there's my sum. Now, remember now, again, we're doing the sample. We're doing a sample here. So a sample variance, I divide this by, see there's 2, 4, 6, 8, 10. I divide this by 1 less, 9. Okay. So I'm going to take my 91.6 still on the calculator. I'm going to divide by 9, and there is my variance right there. 10.1777. Okay. Which, you got to read this right here. Simplify your answer, round to the nearest tenth. All right, so that's going to make this 10.2 because the 7 will make the 1 go up to a 2. So this is 10.2. The variance is what takes the longest to figure out. The standard deviation is just the square root of that. So since I still have this on my calculator, I'm just going to do the square root of that answer. And then, bam, there it is, 3.19. Okay, which the 9 makes the 1 go up to a 2. So this would be 3.2. Okay. All right. That's number 8. Number 9, now here's one here. Now, here's how standard deviation helps us. And this is a good one here to look at. Number 9, both sets of data have a mean of 205. Okay, the mean is 205. If you look down here, we've got these two data sets. Both of these have the mean of 205. Okay, but it says in here, one has a standard deviation of 16. The other has a standard deviation of 24. Okay, which data set has which deviation? Does this one have 16 or does it have 24? Does this one have 16 or does it have 24? Which one has which? Okay, now here's how you can tell. If you look at your numbers here, see these numbers in this data set, they're all real tight. Whereas these numbers over here are spread out more. You can see how they're spread out. This has a couple 16 numbers. This don't have any 16 numbers. This has 3 24 numbers. This don't have any. So they're spread out a lot more than this. So this is going to have a higher standard deviation. So this one here apparently has the 24, whereas this one has the 16. Because the standard deviation tells you how much the numbers are spread out. And so let's see here. Okay, right here, B, part B, I think, is your answer. Because it says A has a standard deviation of 24 and B has a standard deviation of 16. Okay. Now, look at number 10 here. You're applying for a job at 2 companies. Company A offers starting salaries with mu of 30,000, which that's your average. And then it says sigma, which is your standard deviation, is 4,000. Company B offers starting salaries with mu of 30,000, which is the same there, but their standard deviation is 9,000. Okay, for which company are you more likely to get an offer of 38,000 or more? Well, here's what you got. In this first company, since that's 30,000, your standard deviation is 4,000. So if I take that 30,000, I subtract 4,000, that would be 26,000. If I take the 30,000, I add 4,000, that'd be 34,000. So this is what you're most likely going to get offered, most likely in this range. Okay, which is not what you're really wanting, because this is 38,000, what you're really wanting to get. But now if you look at this other company, if I take 30,000 minus 9,000, that's 21,000. If I do 30,000 plus 9,000, that's 39,000. And this is the range you're most likely to get an offer. in this range, which the company you're more likely to get this offer would be this one here. So it'd be company B, because the data values that lie within one standard deviation from the mean are not considered unusual. And what that means is your standard deviation, if you add or subtract that, that is what you're most likely going to get, because that's what's most likely. Okay, now number 11 here, I've already done this one entirely. Okay, I'll just step you through it looking at it. First thing we'll do is put these numbers in order. So you can see how I marked them out here and I put them in order. All right, then we want to add them up, which I did that here, divide by 8, because there's 8 of them. And this is my X bar. Now notice this is a sample. This is a sample, so it's X bar. Okay. So now I take this and I subtract it from each one and square it. So I did that here, all these, and I add them up, I get 158. All right, then here you go. I'm going to divide by 7. Because this is a sample, I take 1 off when I divide here, and so here's my variance. This is my variance. I do the square root of that, which is my standard deviation right there, 4.8. And so it looks like B is my answer right there, B, 4.8. Okay, now number 12 is the same thing. I got the numbers all wrote out here, but I think I'm going to just finish on and do this, but I think the video is getting kind of lengthy, so we'll skip 12. But let's go back to number 1 and 2 now. Number 1, it says describe the difference between the calculation of population standard deviation and that of a sample standard deviation. Describe the difference. Okay. Now this is something I didn't tell you, but capital N is the number of data entries in a population, and lowercase n is the number of data entries in a sample set. So capital N is when we have a population, little n is when we have a sample, and that's how many there are in the group. Okay. Now looking at what this says here, I believe looking at my choices, I think A is the answer here. I think A is the answer. Because when calculating the population standard deviation, the sum of the squared deviation is divided by n, and then the square root of the result is taken. All right, when calculating the sample standard deviation, the sum of the squared deviation is divided by n minus 1. Okay? Now, what that means here now, it's like we did one here a while ago. This was a population we did, and when we add all these up, I divide by 10, because that's how many was in there. This was a population. Okay, versus where's the other one I did? Right here on this one. See, this one was a sample. Okay, so right here when I divide by 1 less. There was 8 in here, but I do 8 minus 1, which is 7, and I divide by 7 to find the standard deviation of a sample. Okay, so that's what number 1 is doing here. And then part A, I think A is the answer here. When calculating the sample, you divide by n minus 1. When you calculate the population, you divide by n. Okay, so A would be the answer there. All right, now what about number 2? Number 2 says, given a data set, how do you know whether to calculate sigma or S? Okay, well, here you go. Sigma, that's population, whereas S, that's sample. Okay, so let's look and see which one says that in here. And, okay, I think it's B right here. When given a data set, one would have to determine if it represented a population or if it was a sample. If the data is a population, then sigma is calculated. If the data is a sample, then S is calculated. Okay. All right, well, that's measures of variation. And Hopefully you don't have any trouble, but if you do, just contact me and I'll try to help you individually. But you all have a good rest of the day, okay?